Hi everyone, my name is Zhehua Mao. I'm from University of Technology Sydney. Today, I will present our paper entitled DSR, Direct Simultaneous Registration for Multiple 3D Images. In this paper, we propose a novel direct simultaneous registration method that registers a collection of 3D images in a simultaneous fashion without specifying any reference image, feature extraction and matching, or information loss or reuse. We formulated the simultaneous registration as a direct boundary adjustment problem, in which intensities of panoramic image and poses of local 3D images are optimized simultaneously. Our idea is straightforward. We want to estimate the poses of all local 3D images through maximizing the similarity between the panoramic image and the local images. In our formulation, DBA is a nonlinear least squares problem. Although DBA seems more difficult to solve than traditional multi-image registration problems, since a much higher order state vector is involved. In this paper, we proved that when solving DBA with Gauss-Newton iterations, the optimization of poses is independent of the intensities of the panoramic image. Such an independent property of DBA is very attractive, since it allows us to optimize the poses only, which can greatly help us reduce the dimension of solution space. Based on the theorem, we propose the direct simultaneous registration algorithm. In addition to the mathematical proof of the theorem, we performed the numerical validation as well. In the first experiment, we solved the full DBA by using the Gauss-Newton method. Before each iteration, we reset the panoramic image to random values. It is found that after each iteration, the image returns the correct result, which indicates the independence of pose optimization from the panoramic image. In the second experiment, we solved the same simultaneous registration problem by using DBA and DSR respectively. It is shown that two algorithms have the exactly same objective function and step changes of poses in each GN iteration. Registration of a collection of 3D images is especially valuable to overcome the drawback of small field of view of 3D transducers. Thus, 3D images are used as examples to validate the proposed DSR algorithm in our paper. In the simulated experiments, 5 collections of 3D images are simulated based on a real 3D CT scan of heart. It is evident that DSR improved the accuracy of registration by more than 50% compared to the other 4 methods for most cases. In these 5 methods, pairwise, Lie normalization, and sequential methods are deduced from pairwise registration methods, while APE and DSR are simultaneous registration methods. In our in vivo experiments, 46 3D images from 6 patients are collected, and ECG gating is used to avoid cardiac motion in the collected images. In this part, DSR is compared with sequential and APE methods only. To evaluate the accuracy of the methods, pairwise images are aligned using the poses obtained by the sequential, APE, and DSR methods respectively. Through comparing the alignments, it is found that aligned images obtained from the DSR are more accurate than the sequential and APE methods. Here are some examples. To further evaluate the accuracy of the proposed DSR method, in vivo 3D images in each dataset are fused using the poses from DSR. We manually select areas which contain sharp boundaries, like the left atrium in the fused images for evaluation. 2 of the registered images in the fused images are highlighted in color boundaries. By observing the LA walls, it is found that the staging area have smooth transition, and no misalignment is found in the images, which suggests good quality of alignments have been obtained by DSR. Through counting the number of voxels, it is found that the field of view of the fused image is enlarged around 2 times as compared with the original single TE images. In clinic, DSR can be very useful to reconstruct a complete structure of left atrium to facilitate device size selection and strict planning for left atrium appendage occlusion. Thank you for your listening. If you have any questions, you are warmly welcome to contact us.